Hi folks, and welcome to another online maths tutorial from CD Masterworks Limited. And today we're going to focus on an element of the relationships and calculus unit where we're going to be focusing on stationary points. So for this we'll just jump straight to gold exercise where we're going to look at the questions in their entirety. So before we start, you should be familiar with the fact that stationary points occur when f dashed x, the gradient of the tangent, is equal to 0. So you should already know that. So the typical question would look like this. Find the coordinates of the stationary points of the curve with equation y equals x cubed plus 3x squared minus 9x plus 7 and determine their nature. This is a big one in your examination, folks. It can be worth anything from 5 to 8 marks. So we've got to get this process just right. So step number 1, what we're going to do is we're going to find f dashed x. So that's 3x squared plus 6x minus 9. Secondly, we've got to make our statement. We have to actually physically write at stationary points f dashed x equals 0, otherwise we'll lose a very unnecessary mark. So once we've done that, what we're going to do is we're physically going to set our differentiated function equal to 0. So the first three steps are very straightforward. So now we've got to find x. So once we've set equal to 0, what we normally do is factorise. So in this particular case there's a common factor of 3, so it would be 3 bracket x squared plus 2x minus 3, and then it's just going to be a trinomial, giving you 3 bracket x minus 1 x plus 3 equals 0. And we've left out those steps because we should be familiar with factorising at this point. So once we've found x, we're going to find y. So we have our 2x values of 1 and minus 3. We're going to find y, and we do that by subbing the x values into the original equation. So if we substitute x equals 1 into the original equation, we would have 1 plus 3 minus 9 plus 7, which gives us 2. And if we sub minus 3 in, that would give us minus 27, add 27, add 27, add 7, which gives us a value of 34. You might want to show some work in there, but obviously if it's in the calculator paper, we can let our calculator do the work there. So we've found the coordinates of the stationary points, but now we need to do the second part to the question, which is determine their nature, and we do that by a means of a nature table. So our typical nature table looks like this, with 3 rows, x, f dashed x and slope, and then we put in our stationary values in ascending value. So minus 3 first, and then 1. What we need to do is we need to think of a value that's less than minus 3, which is quite easy to work with. So we could choose minus 4, we could choose minus 5. Personally, I think minus 10 is a lot more straightforward to work with. Again, we need to look at a value in between minus 3 and 1 that's easy to work with. So I would say 0 is probably the best you could get there. And a number that's more than 1, greater than 1, which is easy to work with. 2 is quite simple, but we'll stick with 10, my own personal favourite there. So what we need to do is we need to sub these numbers into our differentiated function to get an idea of what the gradient would be like or what the slope would be like at that particular point. So if we sub minus 10 in, it would give us 300 minus 60 minus 9. Now you could actually work that out, but I would hope you would see from just what I said there that the slope is in fact going to be positive. The gradient is going to be positive, which means that the slope will go up the way. So then we substitute minus 3 into the differentiated function, but we should know that at stationary points f dashed x is just going to come out as 0. So if there's a gradient of 0, that means that the slope is horizontal. Then we substitute 0 in, so as you can see there, that's going to be 0 plus 0 minus 9, so it would be negative, which means that the slope points down the way. 1's a stationary value, which means that f dashed x would be 0, and then again we're going to get another horizontal slope. And if we substitute 10 in, we're going to get 300 plus 60 minus 9, which is very clearly positive, which means that the slope will point up the way. So as you can see here, this gives us 2 stationary points, which we've got to answer the question for. We have a maximum turning point at minus 334, and we have a minimum turning point at the coordinates 1, 2. And that's 8 marks, 6 marks in your exam, folks, and that's how we do it. So now, you're going to go and try these 6, and you're going to pause the video now. Okay, you've unpaused the video. Let's see how we go on with this quite long-winded question. So the first one, you should get a maximum turning point at 1 minus 2 and a minimum turning point at 3 minus 10. Second one, we should get a maximum turning point at minus 240 and a minimum turning point at 4 minus 292. So number 3, we should get a maximum turning point at minus 111 and a minimum turning point at 17. Number 4, maximum turning point at minus 263 and a minimum turning point at minus 5 minus 505. So number 5, we should have got a rising point of inflection at 0.5. I wonder who had the bottle to write that. And a maximum turning point at 332. And number 6, we should have got a maximum turning point at a third, minus 11 over 27, and a minimum turning point at minus 225. So a bit more complicated with the fractions there. Okay folks, and there you have it, stationary points. So I hope you found that useful, and stay tuned for the next one. Okay, bye.